AI is absolutely fantastic when it comes to finding patterns in, let's say, neat and tidy spreadsheet data. But the real world? Well, it's messy. It's complex. It's full of curves. So today we're going to dive into a really elegant mathematical idea that helps AI understand the true shape of our world.
So let's get right down to it. What's the problem? Well, most of the classic AI tools we use, they're built for what's called Euclidean space. Just picture a flat piece of graph paper, right? It's perfect for straight lines, simple coordinates, but here's the catch. A lot of the world's most interesting data, it's not flat at all.
Okay, so you might be thinking, why is this such a big deal? I mean, can't a super powerful AI just, figure out a curve? It's a great question. And the best way to answer it is with a really clear example.
Okay, so take a 360-degree photo. In its pure form, it's basically a sphere of information, right? Everything captured around the camera. But to feed that into a standard AI, we have to do something kind of violent to it. We have to unwrap it and force it flat into a rectangle. And this is where you see the problem, plain as day. You get these massive, bizarre distortions, especially at the poles, the top and bottom. What the AI is seeing isn't reality, it's a stretched, warped mess.
And that right there, that's the fundamental challenge. Trying to force this curved data onto a flat surface, it's exactly like trying to flatten an orange peel. Have you ever tried it? You just can't do it without tearing it or stretching it all out of shape. You end up distorting the very information you wanted to analyze in the first place.
So, what's the solution? We can't change the data. That's just how the world is. So we have to change the AI. We literally need to teach our algorithms to think in curves.
And the solution comes from this beautiful concept in geometry called a manifold. Now I know, that sounds super technical, maybe a little intimidating, but trust me, the core idea is actually really intuitive. A manifold is just a space that, even if it's wildly curved when you look at the whole thing, it appears perfectly flat when you zoom way in on any single point.
Just think about the Earth, right? From space, it's obviously a giant sphere. But when you're just walking around your neighborhood, does it feel curved? No way. It looks totally flat. You can use a flat map of your city to get around, no problem. And that's the key idea. The Earth is a manifold. It's globally curved, but it's locally flat. And that is the exact property we are going to exploit for our AI.
Okay, so that's the big idea. But how do we actually do it? Well, mathematicians have come up with this really clever toolkit that lets us do all our math on these tiny, convenient flat patches, and then, this is the magic part, map the results right back onto the big curved surface.
This image basically shows the whole trick. So for any point on our curved surface, the manifold, we create this tiny little flat map that just barely touches it at that one single point. In the biz, this is called the tangent space. You can just think of it as our temporary, flat workspace. It's the place where our standard flat world AI tools can finally get to work.
Let's walk through this. It's actually a pretty cool 5-step process. First, you pick a point on the curve, right? Step 2, you create that local flat map we just talked about, the tangent space. Then, step 3, you use something called a logarithm map to kind of pull a nearby point from the curve down onto your flat map. Step 4 is the easy part. Now that everything's flat, you can just run your normal AI operations. Then finally, step 5. You use an exponential map to push that result from the flat map right back onto the curve where it belongs. It's this elegant little dance. Go from curve to flat, do your work, then go from flat back to curve.
Okay, so that's the theory. A little bit of math, but it's pretty cool, right? But the real question is, what does this new curved thinking actually let AI do? Well, let me tell you. The results are absolutely spectacular. Remember that warped, distorted 360-degree photo from the beginning? Well, by treating that image like the sphere it actually is, the AI can analyze it without any of that warping. None. This means way more accurate object detection for things like self-driving cars or VR, because the AI is finally seeing the world in its true native shape.
And it's not just about fixing problems, it also unlocks some incredible creativity. Take artistic style transfer. The AI can now treat both the original photo and the painting style as their own unique shapes, their own manifolds. By understanding and aligning these two shapes, it can merge them together in a way that's so much more coherent and high quality. You get these really stunning pieces of art as a result.
And this idea isn't just for 2D images. It pushes right into the third dimension. Manifold learning is absolutely crucial for teaching an AI to understand and even generate complex 3D models. So whether you're talking about creating characters for video games or analyzing human poses from a video, it all comes down to learning that intrinsic geometry. The true underlying shape of the thing.
And honestly, the list of applications just keeps on growing. This technique is popping up everywhere. It's revolutionizing how we recognize human actions in videos, it's making image similarity searches way more accurate, and it's even helping make those AI-generated images we're all seeing, well, more realistic and easier to edit than ever before.
But you know what? Maybe the most mind-bending application of all has nothing to do with images. It's about using these same ideas to see the invisible shape of any complex dataset you can imagine. We're talking stock market data, genetic code, you name it. So how do we do that? It's through a process called nonlinear dimension reduction. Okay, another technical term, but the goal is super simple. You take data that has like thousands of different features, something a human could never visualize in their head, and you create a simple 2D or 3D map of it. But here's the crucial part. That map has to preserve the data's true underlying shape. And this is where the power of this idea becomes crystal clear. Just look at the columns on the left. The older methods, they try to flatten this data, and just like our orange peel, they tear it to shreds. The original structure is completely lost. It's a mess. But then look all the way to the right. A manifold-aware method, it perfectly preserves the beautiful, intricate shape of the data. For the first time, we can actually see its true form.
This all leads to a really profound idea called the manifold hypothesis. And what it suggests is that most of the super complex, high-dimensional data in our world, we're talking everything from images to language, it doesn't just fill up space randomly. No. It actually lies on a much simpler, smoother, lower-dimensional manifold that's just kind of embedded inside all that complexity. So in a way, the complexity is an illusion. And underneath it all, there's this elegant shape just waiting for us to find it.
So, if there's one thing to take away from all this, it's this. Data has shape. And by learning to respect that shape, by teaching our AI to think in curves, we're unlocking a completely new level of understanding and capability. It really makes you wonder, right? Now that we have the tools to see these hidden structures, what other secrets are just waiting to be discovered?